All right, so I'm gonna go back to this one because I forgot to record a video for it. I have no idea how I forgot to do it. I think because it said I started it. Oh, it doesn't even say I started it. Well, I forgot to do this video because I'm dumb. Like, oh, this is the unit activity. So yeah, it did say I started it. So we'll get into this one. If we don't finish, like I said, I'll record the video over the break. All right, so getting into this. Oh, I don't know how many of you guys have like seen it, but I do recommend using the guided notes. You can find it in the little folder right here. Honestly, what I would recommend doing is like if you guys are watching my tutorials or doing the tutorial on your own, printing this out and working on it, and then just using this for the mastery test. Like you can fill it out, and then like let's say I wanted to fill this stuff out. You'll see why I'm filling it out in a second. And then I wanted to print it. It saves the information. But let's say I didn't have a printer and I'm like, but I really want to have this saved somewhere. Instead of clicking a printer, just click save as PDF and it saves it onto your computer. So, or if you just want to print it out and do it by hand, these are really good tools for doing it. I don't think I've really talked about them enough. I think I've mentioned them a few times in other videos, but you guys should use them. I think they're great and they're really good for when you're stuck on a tutorial and you need to kind of understand what you're doing. Or if you're stuck on a mastery test, it's like, let me look at my guided notes. All right, so we're gonna do a warm up here. So the local animal shelter is a dog has a dog themed party. H represents humans, D represents dogs. The event imposes two restrictions. There can only be 120 dogs and humans combined. So, in other words, can only be we're gonna have dogs plus humans has to be less than or equal to 120. To keep it manageable, there must be one human for every 3 dogs. So we don't want to have like 50 dogs there and like, well, I guess we don't want to have like 100 dogs and like only 2 humans. So that's where they're bringing in this situation. They're like, okay, so humans, dogs divided by 3 has to be human. So every human can bring like 3 dogs, I guess. So these are our 2 restrictions. Restriction 1 is dogs plus human or dogs plus humans is less than or equal to 120. And the situation represented 2 linear functions. One of the situation, write the second one. Oh, so I rewrote the second one. I thought they were going to have a solve for how many dogs can be there. So we're going to say that D plus H is less than or equal to, because what if nobody wants to come to your party? Less than or equal to 120. Where's the less than or equal to 120? Ah, less than or equal to 120. I have a feeling though Edmentum's going to be dumb. It's like, put it with an equal sign. What'd I tell you? I guess they're assuming that you're going to have exactly 120 people go. There you go. So they have it with an equal sign. I think because in this one we're going to learn about inequalities, we're going to learn about the less than or equal to situations in a bit. All right. So let me delete all this. So again, I know I always skip it when I make these videos, but you guys should take a look at it. They do. I think they explain it pretty good. Oh, and look, they explained the less than, greater than, or equal to sign. We did that on Kahoot. All right. So, system of equations. So, the idea of a system of equations is just two graphs. Usually, right now we've only really dealt with linear system of equations, and where they meet up, that's where it satisfies conditions. This unit, we're going to talk about inequality. So inequality is like, let's say we want everything greater than this line, but we want everything below this line. So that means our answer is this spot right here where everything is double colored in. So this might be review from when you guys did this on Algebra 1. So everything double colored in here is our answer. So looking at this, let's say we have two different graphs. We have this graph, which is how far this dolphin can jump. And then we have this graph where the hawk can go down. Movement of these two animals. So this is the movement of these two animals over time. We want to figure out when they're like kind of in the same area where they can hit each other, basically. Or if they did hit each other when they moved at those spots. So linear equations. This is a review of the types of equations. I think this is really useful for you guys to know. That way you know when you're like, oh, if it's a constant rate, it's a line. So if you're paying like, I don't know, like 5 cents a minute on your phone plan, it's going to be a line because it's a constant rate. Let's say if something's exponential, that means you're doubling every so often or something's happening. It becomes exponential. There are exponential decays. Like, for example, let's say, I'm trying to think of an example. Let's say you keep cutting something in half. If you keep cutting something in half, you're going to get less, 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 and less. In theory, eventually you have nothing. And this is something that's like, if you get all philosophical, it's like, can you ever cut something in half enough to where you get zero? In math, the answer is no. You can never get. You can't. You can. You have zero. If you have zero, you cut it in half, you have zero. But I always thought about it interesting. It's like, if I cut something in half enough times, shouldn't I eventually I get zero? In theory, I guess so, if you get down to atoms. But mathematically, you can never cut something down to zero because you're always going to get half of something. Yep. Oh, it's fine. Like I said, I'm recording this, so you're good. Quadratic formulas. The idea of a quadratic formula is from this word quad, meaning four. I think it's kind of dumb because it's really confusing. Because then you're like, four, but that's a squared. Well, the idea here, the reason why they're called quadratics is because of a square has four sides. So if you guys ever wondered why that is, it's because there's four. So in a quadratic, there should always be a squared. So quad meaning from four meaning square. So quad. So that's why you'll get to quadrics. Quadrics means to the fourth power. So this was just how they used it back in the day. They're like, oh, quad meaning a square. Higher power functions kind of do little curves. So a degree of 3 has 3 curves. 1, 2, 3. So there, and there. A quadratic has two curves, one where it's going down, one where it's going up. And sometimes you don't see the curves, like they happen very subtly. This is still degree 3, it's just the hump was very small. So just know that, I guess. Going to the next one, you have rational functions. So when you have a fraction, I don't know if I've really gone over this, why it looks like this, but the idea here is think of it this way. Um, in between this 1 and this 0 are fractions, right? So if you have a fraction divided by a fraction, you actually end up getting a really big number. So 1 divided by 1/2 is 2. Think of it this way. If you have a piece of pizza and you're like, I want to divide this in half, how many halves do I have? So I have one pizza, I have 2 halves. So if I have one pizza and I want to divide that in fourth or eighths, I don't know why I said fourth, but I wrote 8. How many eighths do I have in that pizza? All right, so if I divide that out, I should end up getting like 8 slices of pizza. So that's how come this number gets bigger. Oh, I picked the wrong side. This number here would get bigger. In theory, if you have like, I want to divide this 1 and I want to divide it into divisions of 1 million, you would get it all the way up to 1 million. So that's how come this goes up bigger. The only reason why this is the same thing but on the negative side is think of it negatively. So if I divide something by a negative number, a positive number divided by a negative number becomes negative. So that's why we have all these negative numbers. And the reason why this never touches a 0 is like what I said before. If I have 1 divided by a billion, it's a million. 1 divided by a billion, still technically not 0. It's very, very close to 0, but it's not 0. So that's why these graphs behave the way they do. Next one is radical functions. Radical functions just grow slow because if you think about it, y equals the square root of x. Square root of 1 is 1. Square root of 4 is 2. So this one jumped all the way from 1 and we got 1. Then we went from 4 and we only got a 2. So that's why it's not really growing that fast. And then we're going to jump all the way to 9 and barely get to 3. So it doesn't grow that fast. It is growing, just very slow compared to how the other one's growing. All right, but enough about graphs. We're going to talk about how they interact with each other. So these are all the graphs. I recommend kind of getting to know these graphs a little bit. These are the 6 main graphs you should kind of have an idea of. So if we're talking about projectiles, I think I kind of talked about this a little bit before, where a projectile is dropped or thrown. Actually, give me a second. I feel like I've already done this video. Zoom recording. So if we're dropping something, we're not really adding any velocity to it. It's just kind of falling from wherever the height is. If we're throwing something, we are adding some velocity, like we're throwing it up and then comes back down. So that's why you'll notice that this part gets added to a formula if we're throwing something. So if we throw something up, it will come back down. We're adding a velocity going up. Gravity is the force pushing it down. So when we're growing something, at first it grows really fast, but then it starts growing very little because we have that force of gravity, eventually to the point where we have to go back down. But if we drop something, it's just kind of like bloop. So this is a way of measuring it over time. And we're measuring over time. We're not literally seeing the object go that way. In fact, it's basically, give me a second. The reason why we have to measure it over time is if I graph this the way it moved, it would look like this. And that is not that helpful. So that's why we do it over time. How high it is over time. So usually when we're talking about projectiles, we're talking about it over a given amount of time. All right, so she's gonna be the first ball. So we're gonna be talking about two balls here. The first one, it's being thrown up in the air. So that's how we measure the height. The second ball is not being thrown, or is being thrown as well, but just at a slower velocity. So they're throwing it a little slower and a little higher. So they're throwing it slower but higher. This one's being thrown faster but from a lower height. Maybe it's a shorter person doing it, although that'd be very different in height. So we have these. So it's a shorter person throwing it fast. And this one's a taller person throwing it slower. So that's how this affects the graph. So it's like, would these balls have ever been at the same height around the same time? And yes, they did cross each other. So solving this by graphing is pretty easy to do. It's just like right there where they cross. We're going to solve this using different functions, which I remember this one is a little tricky. So, all right. So Rachel decided to start saving money for college. She has $1,500 in her savings. Jeffrey has 1,200. So Rachel's starting off a little higher. The bank offered her an interest rate of 7.5% compounded annually. So every year she's going to get this money. Jeffrey decided to keep his money in a safe in his bedroom, and he adds $200 a year. So he adds $200 every year. Suppose the A represents a function of savings in this year. So we have two different functions. So what's happening here is Jeffrey has a constant rate. His is a line. What's happening is he starts off with $1,000 and then he's going to add $200 every year. So he has to multiply it by the number of years. So if we think about that one's pretty simple. It should be, where is that 200? Here it is. So that one's pretty simple. Now let's go over to Rachel. So Rachel is starting off with more money, but hers is a percentage. It's going to be based off the percentage. This is known as an exponential growth. At first, she's not getting as much, but as time passes on, that money, the interest of that money creates more interest, creates more interest, creates more interest, and then it's like growing super fast. It doesn't like go straight up after a while. It's still kind of growing over time. It just grows so fast that you'd have to zoom out of the graph to see how far it's moving. So this is known as an exponential growth, and you always want to do it as a percent. Um, I don't like doing things as percentages. It's just how the world kind of does things. I like them as fractions or decimals. Decimals are more useful. All percentages are a fancy way of saying that divided by 100. That's all a percentage is. So technically, you should be using a decimal. So we're going to do 7.5 divided by 100. So that's 0.07. Now the thing is, it's not like he's Rachel's only getting the interest. She's getting the interest plus the initial amount. So every year we're going to be multiplying it by 105. The 1 comes from it being the same thing, right? So times 1 is still that. So we're adding the original amount plus the interest. And we're going to keep multiplying it the number of years. So it's an exponential growth. Every year we keep multiplying it by this number over and over and over again. So Rachel's is going to be this one. It's an exponential growth based off the percentage. And it's a growth because it's greater than 1. Does that make sense, guys? I know this, it's really kind of weird how to think of exponentials, but does everyone kind of understand why this one's linear and why this one's exponential? Okay, cool. It's like, did I accidentally close the chat? All right, cool. All right, so moving on to the next one. So let's think, can solutions be negative? Can the solutions be decimal values? So sometimes you have to do what's known as a viable solution. So let's say, for example, I'm saying the population is going to increase by 7% every year. So what's going to happen is, let's say we have 100 people. So after a year, we're going to have 107 people. I don't know how to write, apparently, guys. I'm sorry. We're going to have 107 people, right? We're multiplying it by 1.07, 7%. The year after that, 107. So that works out fine the first time. But then if we do it again, can we have 0.49 of a person? We can't. So that's why this is what's known as viable. We can't have a small percentage of a person, so we're just going to have to round it up. So that's what's known as a non-viable solution. Sometimes we can have negative numbers, like, for example, money in your pocket. You can't have negative money in your pocket. You can owe people money, so you can't have negative money by debt, but for the most part, you can't have negative money. If you're measuring how tall someone is, they can't be negative 5 inches tall. So you have to think about that. So let's say, for example, this graph represented population over time. We can't have negative time. So even though the graphs act normal, like this is a graph that would represent it, in real life, you can't have negative time. So this isn't an answer. But these two could be an answer. It's like, oh, okay, cool. I mean, back in the day, maybe in the past this works, but in the future, we don't care about negative numbers. So these would be our only two viable answers. So that's what we mean by if a solution is viable or not viable. You kind of have to think about it in real life. So let's try to do this lesson activity here. So we're dealing with all of these shapes and volumes and all of this stuff here. So the side of the middle-sized cube's edges are 2 inches longer than those of the smallest. And then the largest cube. So we have all of these things going on at the same time. The volume of 3 cubes combined is that. So let's kind of talk about these. Okay, so I need variables for each one. Luckily, we're talking about cubes, so we can make everything like its own letter. So I'm going to call this cube A, cube B, and cube C. If I want to find the volumes, it's whatever the side is squared. So this has the side lengths of A, B, C. You guys get the idea. They want to use less letters. So they're saying the middle cube edges are 2 inches longer than those of the smallest cube. So I'm going to say A is my smallest cube. So I'm going to say that B equals A plus 2. All right, so now it's saying the side length of the largest cube is 2 inches larger than the medium cube. So this is going to be B plus 2. The sum of one side of each of the cubes equals Y. The sum of one side length of each. Oh, okay, so that's A plus B plus C equals Y. All right. The volume of the cubes combined is 24 times Y. Length times width times height, 24 times Y. Okay, so now we're going to do some work here. So write a system of equations with the information you know. So that's everything I did here. So I'm going to say B equals, they didn't give us variables, did they? They did not. Okay. So I'm going to say B equals A plus 2. I'm going to say that C equals B plus 2. And they want us to do the sum of the sides is equal to Y. So I'm going to say A plus B plus C equals Y. And then it's going to tell us that the volume of the three cubes is that. So in this case, I'm going to say length times width times height. So I'm going to say something like A. You have to use the equation editor for this, apparently. I'm going to say something like A cubed, length times width times height. It's a cube, so it's the length, width, and height are all the same. So that's why I'm doing cube. Plus B cubed plus C cubed equals 24 times Y. So right now they're just having us set it up. So this is how you would use it if you were presented a problem like this. Like you're like, I need to do this, but this one is so much bigger than this, and this is so much bigger than this. This is how you would set up your problems in real life. You're creating relationships. Those relationships have to be written down in math, so it makes it a little easier to understand. So now set one equation in the formula to the other. So I don't know what they want us to do here. This one's just weird. That. I honestly don't know what Edmentum wants me to do here. Their wording is always really weird. Graph this. So write a system of equations based on the information you know. Okay, I'm assuming this is really bad. So, all right. So I'm gonna kind of get you guys uh, in the mindset that they wanted. This is a system of equations. They wanted a system of two equations. And what they wanted there was in a system of these two equations. So they should have specified that first of all. So in order to do this, well, I have too many variables here. I'm going to want everything equal to A in terms of A. So instead of writing this as plus B, I'm going to write this down as A plus 2. Now, the reason why I was allowed to do that was because of this equation right here, B equals A plus 2. Now, This one, I'm going to write it down as b plus 2, but I want this all in terms of a. So what's going to happen here is this is going to end up being, I'm going to change this b to plus 2 again. So this ends up being b plus 4 because we have, let me write that down, because we have c equals b plus 2, but then b equals a plus 2 plus the other 2. So this ends up being this a plus 4. I think I said b plus 4. I meant to say a plus 4. I'm sorry. So in other words, this means that y equals 3a's plus 6. Now, here's another problem. We have this equation right here. Let me erase this. We have this equation here, but we have way too many letters. So what I'm going to do is I'm going to call this x to the third power. Oh, you know what? I'm going to change that a to an x here. So I get y equals, and I'm just changing it just so it works when I graph it. I have 3x's plus 6. So that's how I get this y. Is this making sense so far, guys? I know I'm kind of like going all over the place. Yes, no. Did some of you guys like just go to sleep? All right, cool. Yes, you did go to sleep, Nelson. So this one is x plus 2 cubed, and I'm going to add it to x plus 4, and I'm going to cube that. And this is equal to 24y. So if I want to set this up equal to y, this would be y equals, and it's a giant fraction. And because I'm lazy, I'm literally just going to copy this. I'm going to divide that by 24. So that's what I'm getting here is I kind of replaced all the a's with x's. And then b is just a plus 2. So I'm calling it x plus 2. And then c, this is where we get to like Inception's levels of thinking. So c equals the b plus 2, and b is equal to b or a plus 2, a plus 2. But then we're going to add a 2, so that means we get a plus 4. But since I'm calling a x, it's x plus 4. So it's like it's an equation within an equation. All right. So all of that just to make our two equations, which Edmentum forgot to tell us is what they wanted. So I have these two equations. I have this one, y equals 3x plus 6, and I have this really long, complicated equation. So let me submit that, and you'll see that I wrote the same equations they did. They just forgot to tell us what they wanted. So these are two equations. They just kind of plugged it in a little slower. Next, we're going to want to find the relationship between these two. So we're going to say relationship. I'm not going to, you could do linear because it is a linear relationship, but I like just going custom. Custom is easier because you're just like y equals 3x plus 6. Like that. Now I have a nice little line. I'm going to do another relationship, also do custom, and I'm going to say y equals, get my fraction in there. I should have Did I save it? I did save it because I hit copy and I haven't copied anything else. It was in my clipboard, so I just did Control V and it copied down what I had before. And then this, and because it's an equation editor, it was able to do it all nicely. Divided by 24. To plot that, you see that this, because it's a cubic function, you see the curves. 1, 2, 3 curves. And we're going to have these two answers. So this is where viable answers come into place. You can't have a negative side. So the only viable answer would be this one. I thought I could zoom in. Oh, would be this one. Can I move? Yes, I can. This one, which is our A, is 2. And our Y is 12. Which makes sense because think of it this way. If our A is 2, that means our B is 4, which means that our other side is 6. And we said that if you add up all the sides, you get 12. So equations like this are just a fancy way of solving problems where it's like, I want this stuff to happen, but I don't know what the numbers are. So instead of guessing all the numbers, we can just use a system of equations to figure it out. I'm going to submit that, and you'll see it's the same thing. So what are the solutions to the system of equations? So the solutions are x equals -2, but you can't have a negative side, so it is not viable. -2 and 2, but you can't have a negative side, so -2 is not viable. The reason why they give you this much space is because technically you have more answers, but you have to think in real life you can't have a negative side, so we're going to say that's not viable. Oh, and I guess there's also a -6. I didn't even see that -6. So whoops, you guys get the benefit of seeing my mistake. They have them as points. I don't really see the point in having it because you can just plug in your X into there and get your Y's if you really want to get that. Determine this. So, this is where we talk about viable options. So, -6 and -2 are not viable because you cannot have a negative side length. Side length, you never go like, how much does that measure or how tall is that? It's -2 inches. It's always positive. So, what is the total volume of the cubes? All right, so let's talk about this. We figured out that our y had to be 12. So, what we're going to do here is the volume is 24y. Since y has to be 12 because it is the only viable answer, the volume is whatever 24 times 12 is, which is calculator. I'm not the biggest fan of the Edmentum calculator, but it's useful when you're in a rush. 24 times 12. I use the keyboard to enter it in, which is 288. For self evaluation, I would probably like score this as a 4 or something because luckily I stopped myself. And the only reason I stopped myself is because I knew I was recording this and I hate when I have all these mistakes on camera. Um, because I had to stop myself and really think of what they were asking. So because I accidentally saw what they did in part B, I was like, oh, they want two systems, two equations. And I forgot to mention that this was an angle. So I would probably give myself like a 4 here. Had to stop and think after seeing part B. Also forgot an answer. So the purpose of it showing you guys the sample answers is not so you can just change your answer and get it right. The purpose of it showing the sample answer is for you guys to be like, huh, I totally thought that was the wrong thing and like learn about it. So that's what why each of these has a self-evaluation so you can reflect on how you think you did compared to how the answers were. All right, so I will finish the rest of this video um, during the break. And like I said, I'll try to do module 2 and finish module 1 over the break as well. So you guys have a bit of videos that you guys can still watch, and I'll do the Kahoots based off of that.